Uh, Here we have our second video from our correlation and regression section, which is chapter 9, according to the curriculum that we have. So what we're going to look at here is how to test a population correlation coefficient rho using the Pearson R table, how to perform a hypothesis test for a population correlation coefficient rho. We're going to use a p-value there, how to find the equation of a regression line, and how to predict the y values using a regression equation. Now, I'm going to do another video on the equation of the regression line and prediction, but you're going to get a pretty good idea on how this is done using Statcrunch after this video. So we're going to have two methods, p-value method using Statcrunch and the test statistic method using Statcrunch, but we have to supplement that with the Pearson R chart for critical values. And the Pearson R chart is built into both the homework questions and the test questions. So remember, when looking for correlation, it is a hypothesis test, just like we did in the last chapter. But the nice thing is the hypothesis is always set up the same way. The null hypothesis is always that rho equals 0, that we're assuming that no linear correlation exists. The alternative hypothesis is always rho is not equal to 0. Some linear correlation exists. And for linear correlation, regression, this never changes. This will always be the same. So anytime I reject the null, I'm saying that some linear correlation exists. If I do not reject the null, then there's no linear correlation. Now, I've got the Statcrunch instructions right here. I'm going to go ahead and let's go ahead and see if I should have done this already. Let's do it now. Let's put steps there. Okay. So there's your steps for Statcrunch. We're going to do this in just a second, but let's look at how the conclusions are formulated. So if the computed p-value is less than or equal to the significance level, that is p less than or equal to alpha, reject the null hypothesis that there is no linear correlation and conclude that there is a linear correlation. When we decide to fail to reject the null hypothesis, we're saying there's not sufficient evidence to support the conclusion of a linear correlation. So how do I interpret that? Well, you see the letters, the words in all uppercase. My sample data either does or does not provide sufficient evidence to suggest that it could be a positive or it could be a negative linear correlation exists between the two variables that we're looking at. Remember, that's what this is about, a relationship between variables and the significance level. Now, before we move on to this homework problem, it's important that we remember that correlation does not equal causation, or we have the equation method here of correlation not equal to causation. Remember that. Statistics is never having to say you're certain, and there are frequent times where we'll see the two things where they could seem to be correlated, but clearly one did not cause the other. And you may remember the example back from the beginning of the course with the drinking water and deaths. So we're going to look at the homework problem from chapter 9, number 3, and the images are from the completed problem. The problem will be worked again in the review mode. So this is what the problem looks like, and I'm going to show you there's two links here. So let's go ahead and pull our problem back up. So the accompanying table shows the ages and years of 11 children and the numbers of words in their vocabulary, completes parts A through D. Well, first I need the data. And one of the really nice functions with my stat lab or my math lab is when I click this table, it's going to give me the data here, and all I have to do is click to copy the table and open in Statcrunch. I don't have to type the data in. Now, all the parts from this, I'm done with the data table, so let's close it. Let's find my Statcrunch again. But before I do that, let's look at this table again. The first step, they're asking me to pick a graph. But with Statcrunch, I'm going to be able to do this in an easier way. So I'm going to, if I skip around a little bit, it's because the way Statcrunch is putting out the results. So let's go ahead. And if you remember the steps from Statcrunch, I'm going to go stat, regression, simple linear. That's all we're doing for this course. It's just linear regression. Now, my X variable is their age. That's the independent variable. The dependent variable is how the size of their vocabulary. We're saying this is a function of age. Now, I don't need to change the hypothesis test at all, do I? But there's a really cool thing down here, and this is going to come up later. What if I wanted to use the regression equation to make a prediction? So let's say how many words we would expect. I'm going to look at my data briefly. 1, 2, 3, 4, 5, 6. How many words would we expect? I'm going to put the 4 in there because that's within the scope of the data, just to show you what all Statcrunch does. So I can go ahead and click compute. What I'm saying is when a child's 4 years old, based on the regression equation that's going to be produced here with Statcrunch by the data, how many words would we expect to see in their vocabulary? So when I click compute, I get everything. And I'm going to try to blow this up as much as I can. I guess that's as good as it gets. So notice a few things here. First, there we go. Notice right here, my slope, I get a p-value of very low, less than or equal to 0.00001, right? I already know at this point, if the null is low, it's got to go. I already know I'm going to fail to reject, right? And I also am going to get an R value right here. So everybody see that R value, the R correlation coefficient? And they said round it to 3 places, so it's going to round to 0.976. There's that answer right there. But I skipped past identifying the graphs. When I click this little arrow right here, there's my graph. So I see that there is a positive correlation, which I expected. So it has to be one of these two, right? So how do I decide? I'm looking at this one, and I notice that these here are below the regression line. You notice this one's curved the other way. This one kind of curves down and up, but it still stays close to. That tells me D is the right answer. I can look at the shape of this graph here. So D is the correct answer for identifying the graph. Now I'm going to go back, and we know the R value is 0.976. We already can see, we know that 0.976 is very close to 1. Right now, we can say that there is a strong positive linear correlation. We're getting ahead of ourselves a little bit, but we do have the p-value that shows effectively 0, which means a very low p-value. So we have a strong positive linear correlation that their vocabulary increases as a function of age. Not surprising. As the age increases, the number of words in children's vocabulary tends to increase. Now, how do I find those critical values? The last part here. And that's where I'm going to click this chart right here. Notice there's 2 links. And I need, let's see, I might back into this. How many groups of data do we have? Let's pull up Statcrunch back. It's going to tell me. Pairs of data with the degrees of freedom was 9. There's my sample size is 11. The critical values in Pearson are, I'm just going to go to 11. I know I got a 0.01 significance level, and there it is, 0.735. Notice this table is much easier to use than the one for z-scores. So 0.735, that's my critical value. You see that's correct, right? So the only thing left to do, let's put this away, is to make my conclusion. There is sufficient evidence at the 1% level of significance to conclude that there is a significant linear correlation between the children's ages and the number of words in their vocabulary, round to 3 decimal places. So the problem is finished, but before we go on, I want to pull up the Statcrunch again and show you something else. Remember when I said I could predict a 4-year-old's approximate number of words? Let me go down here with my predicted value of 4, and they're saying that a child at 4, there would average over 1,400 words in their vocabulary. So this is how you use the prediction, and I could change that. How about if I want to see what a 5-year-old does? Then I'm just going to come into here. I'm going to change that from a 4-year-old to a 5-year-old. We're going to do this again when we get to the regression questions, but this is because I know we're getting near the end. I wanted everybody to get a look at what all Statcrunch would do. So finished with that problem. I hope you'll find this helpful. I think that with Statcrunch, you'll find most of these questions very straightforward. Remember, you'll be able to print out the handouts for these videos and use them when you take your test. Again, hope you found this helpful.